Hi, welcome. Let's do a little concept review. In this video, I just wanted to cover a few of the major topics which people get stuck on, and it might help you get a couple of extra points in the exam. So this is just a little quick review, and then I'll follow up with some tips on how to do a great exam. So the first topic, random numbers. Random numbers tend to trip people up because you're a little bit confused about how to get the right random number. They'll be given a task which involves getting from a number, and they won't remember exactly how to do it, or they'll make some mistakes. And so there are a few key mistakes, and so I'll go through the how to not make them. So what you got to remember is that a random number, Math.random, it comes from this library function which we use, which gives us a number between 0.0 and 1.0, and that's a double, obviously. But it doesn't include 1.0, and that's important. It's not including the 1.0, it's going from 0.0 all the way up to 0.9999999. And so when we manipulate this number, we have to be a little bit careful about how we manipulate it in order to get the right result. So let's do an example. Let's say we want to generate a number between 1 and 5. We will get our math.random. Okay, so we've got our raw number. Now we're going to take that number and then we're going to multiply it by 5. That'll give us a number between 0.0 and 4.9999. Now that we've got that, what we really want is the first part of here, because we can convert it back to an int, right? If we want a number between 1 and 5. So we're going to be dropping this decimal place off, right? We're going to removing that. But right now we've got 0 and 4 as the leading numbers. We need to increase that to 1 and 5, right? Between 1 and 5. So we add 1, and we've got a 1.0 to 5.999, and now we can convert it to an int. And so we convert it to an int, and that would give us a number from 1 to 5. However, if you notice here in my in this code here, this is not actually quite right. And to understand why it's not quite right, I mean, I've done all the steps here. Maybe you can see it, but I'm going to explain why this isn't the correct answer. We need two more little things to go in here. And so it has to do with step 4, converting to the int. So let's go through and have a look at how that works. Okay, so let's go through another example. And here you can see it's much better in that I am doing my int here, and I'm using brackets around the formula. Okay, so that's the reason why that solution wouldn't work before. Let's go back here. What would have happened here? Well, what would have happened was I would have done int, right? As I've done my math.random, int would have applied to that first, like a multiplication. In the order of precedence, int would have been applied to math.random. Now math.random has a number from 0.0 to 0.999. Converting to an int at this stage would have dropped the decimal place, and I would have ended up with a 0. So this formula would always equate to 1, because I'd be multiplying 0 by 5 and then adding 1. So every time I would have gotten 1. So the correct way to do it is to put parentheses around the formula. So do your multiplication, do your addition, and then you're going to do the conversion to an int. And then save it into none. Okay, so here's an example of a little bit of code that I'm using random, but what I'm doing is I'm actually just calculating random over a bunch of rounds. So I'm going to go through and do 1,000 rounds of calculating random numbers. I'm doing it with a maximum of 8, so it's from 1 to 8. So basically the number is going to be a random number between 1 and 8. And here's the formula I used from just before. So I've generated my number, and what I'm going to do is I'm going to put it inside this array, which is going to save a place for each number. So when I put the number in there, it's going to put that as the index, and it's going to add 1, a count of 1. So if I generate a 5, it's going to look up index 5 and add the tally, right? So it's basically going to add up how many times I generate these random numbers. So if I do a 1, if I do an 8, and now you're probably saying, well, what about the 0? And normally indexes start at 0. So when I've declared my array, I've added a 1 so that my num will correspond to the right index. I've just added a num. So I'm ignoring the 0 position. And then at the end, I just print it all out. So what I get in the end will be a tally of the random numbers generated. So as you can see, they're sort of, they're not going to be totally even, but it's the luck of the draw. But you can see that it's generated 133 ones, 118 twos, etc. So if you want to explore this example more, there's the code. Go and have a look. Okay, next one. Let's get into some logic. Now this is one area which does confuse people, and often there's probably only one or two questions on the exam about this. However, it's good to know, and it's not a totally difficult process. It's actually just a 3-step winning formula. I think if you can remember the 3 steps, you should be good to go. The key is, when we're looking at logic, we are trying to we can look at it in terms of really like a binary kind of thing, like the opposite of this area in here, which if you look at the two, we have let's say A and B, two different circles. The commonality, or when we say A and B, what's common when they're both true, is in here, right? This is the area of A and B, and this whole set might be A or B, the whole blue area, including the middle. This is A or B, so if A is true, the whole thing's true. If B is true, the whole thing's true. Okay, so this is the whole set, A or B, and this might be the area, this here, boundary, the boundary there is like not A, and this is not B. So you can see there's sort of like these dividing areas. So if I'm looking for the opposite of A and B, it's basically not A and not B, right? So, sorry, not A or not B. Not A or not B. So what that's doing is basically saying this. If I'm looking for the opposite of A and B, I'm saying not A or not B. Okay? Now, you're not expected to remember these all. There's a simple way to look at it. Firstly, invert the not at the front, right? So if there's not a not, add a not. If there is a not, cancel the not, right? Because 2 nots make a nothing. So invert the not, flip the operator, right? So we're changing that to and, from and to or, from or to and, from equals to not equals, from not equals to equals, from less than to greater than or equal to, right? Because if you imagine that this side is greater than, then this is less than or equal to, right? So you have to make sure you include the equal sign, etc., etc. So flip the operator, and then finally not each operand. So not each side of the equation. Okay, so invert the not, flip the operator, and not each operand, and you'll get to your correct conversion. Now, in the exam, you probably have to convert a couple of times, maybe twice, in order to get to the right result, but it shouldn't be more than that. I'd say, like, if you're starting to convert like 4 times, it's probably too much. Okay, next number. Next topic, absolute numbers. Why are they useful? Well, absolute numbers will tell us whether it's basically used for finding the difference between 2 numbers if you don't know which one's bigger. So if you're trying to find the difference between 2 points, but you don't know which one's going to be bigger, sometimes one will be bigger, sometimes the other one will be bigger, then just minus them from each other and then find the absolute. And that should get you the number you're looking for. Absolute is from the Java Quick Reference. That'll be with you in the exam, the only friend you can take. You should know how to use. By this stage, you should know all of the methods there. That's basically your toolkit. So you should be able to get out any tool and the appropriate tool to solve the problem. And so sometimes the knowing which tool to use is part of the finding the answer. Okay, next. Okay, objects versus references. So when we're learning about objects, we come across this idea that we've sort of used variables before, we've used numbers, but then we come across objects, it's like string objects and other objects that we create, and when they're now behaving a little bit differently. So the key to remember is linked to an object is not the object. It's just a pointer. So it's to say like an address to your house is not your actual house. What it is, it's a pointer that will take you there. And so don't get confused between the actual object reference, which is over here, like person P. That's a variable to say I'm going to point to a person. The actual object is in memory over here. And so what we're looking at is this pointer reference. Now, if I ask, is person P equal to person S, if I say are these things equal, it's only going to tell me are they pointing to the same place, basically. Are they pointing to the same object? It's not going to be able to tell me if the two objects are the same. To do that, I'd have to compare these two objects to see if they're the same, and objects have many different variables and things. So to test the equality of two objects, you may need to write an equals method so that it can go through and check, just see if two people are the same in this case. So keep that in mind. References are not the same and they don't behave the same as primitive types. They are references to some object. Okay, loops. When to use the right loop? So just remember that a for loop is used to do something a certain number of times, right? We usually do a for loop because we know how many times we want to repeat something. The while loop we use because we don't know, or it's unsure how many loops we need. So for example, like we might have a bunch of marshmallows in the class and we want to give them out to each student. So we know how many students there are. We're going to say for each student in the class, give one marshmallow. Okay. However, let's say we just want to give out marshmallows until there's no more marshmallows left. Well, then we would use a while loop and would say, while there are still marshmallows, give one to a student. And so we can keep giving them out until they're gone. This is the way that we use these two loops. Quick look at a for loop. Remember 3 parts. Initialization, where we're setting some variable up. Condition, where we're testing that variable, and as long as it's true, we're going to keep running the loop. And then update. After the loop finishes, after we do one round, we're going to update the variable. And it's somehow going to modify the variable and then maybe give a new condition. So this is the visual look of it. And there's the different parts. Now the while loop itself, it only uses one condition, and it doesn't have a counter built in. It just has some condition. So the problem that people mostly get into when they do this is that their counter may or may not update correctly, and sometimes people can get an infinite loop. So really, it's when you're dealing with looping, it's the condition must be changing as you're doing the loop to give you a chance to get down to the case where it will be false, so that you can exit and keep going. But before I get here, like with all loops, when you're dealing with loops, either they're for loops or while loops, pay attention to the edge cases. And what I mean by edge cases, I mean look at the time when it will be starting and when it will be ending. The key is looking at which conditions will it be where it's starting and ending. That's the key to a lot of these questions, is that you'll get slipped up in for loops. For example, when the condition, when maybe the start point is 1 instead of 0, and the condition is the condition is like equal to, less than or equal to, right? So normally we would start with a start point of I equals 0, and then I less than whatever the number is we want to do the loop. So if it's 10, we're doing 10 loops. We know that, like, we can get used to that formula. But if you see different things, then pay attention to where it's starting and where it's ending, and then what's happening at those cases. All right. Also, be careful not to mix up your equals and your equals. If you're doing a Boolean statement to test if something is equal, use this one. Don't use this one. This is assigning a value. This is checking if something is true or false, if they're equal. All right. Constructors. Constructors are the things that build objects, and constructors can have many different inputs because of polymorphism. Polymorphism has the same method but different inputs. Now you can't have two constructors with the same inputs, like you can't have two that take a string. They all have to be different. And it's good to know that also if a class doesn't have a constructor, the class will automatically make a blank constructor for you. So if that's missing, Java will automatically do it and put it in there, and probably initialize these to just blanks or default values. The whole purpose of them is to take the inputs and store them into the data area, which is the instance variables. So it's taking this information and putting it into here. Now in this case, when I'm doing a string first name and I've got string first name up here, Java's going to think, which first name are you talking about? Remember to use the this command to refer to this one, and you can just use the variable name here. So this dot first name is this one equals first name. Now when you look at down here, this is how it's used. What we're actually doing here is just calling these constructor methods here. When we say new employee Harry, that's what's happening. It's calling this constructor. And the thing to note about this is that here's where the variables are being declared, right? These are declarations. I'm saying I've got a new variable called, employee variable called emp1. Here is where the variable is actually getting initialized, where the object's being created. It's given a value. So you see here in classes, we declare variables at the start, but they're only initialized when the constructor is run. Accessor methods. So we can't access data usually in a class because we can't access it from outside because it's private. It's not available to other classes to access. So what other classes need to do is to use these public methods, which are the get methods or the accessor methods, which will then be accessing the data and returning it. It allows the class to control how outside classes are interacting or getting the information. Maybe some information requires some criteria, so it allows us control over how we access data. So basically these are two get methods, get major and get age. They're getting the information from the class and returning it to whatever called this method. Okay, when you're doing inheritance, if you come across inheritance, the big idea is that you remember inheritance is basically we define it as an is-are relationship, and it's kind of easier to think that way. What we're doing in inheritance is putting all the shared kind of information or common things in the superclass, and we're doing the specialization in the subclasses. It avoids us having to write more code. We can inherit things. If we need to update things, it's easier to just do it once. And so the subclasses, you should keep in mind that a square, for example, is a shape. A rectangle is a shape. A circle is a shape. I cannot say for sure a shape is a rectangle. It doesn't go the other way. A shape could be a rectangle, but it's it works the one way, not the other way. Shape is not a circle. Shape is a general thing. The circle has special properties which are not defined in shape. All the public methods and the variables are inherited to the subclass. Now, if you need to access if you want to use the constructor, for example, like let's say in the superclass we have properties, right? Area, color, perimeter, but they're not getting they're not getting initialized. If I make a new square, how is it going to initialize area, color, perimeter? Well, we're going to use the keyword super to access the parent class, and we can use super to run the constructor. So let's go back to where I had the employees. If I had a new subclass under employee and I wanted to run the constructor here to initialize the first name, last name, then first name, last name, then I would call super and then use first name, last name, and it would call this constructor from the super class. So the super keyword is generally used, but you know what, if you don't use it, it'll automatically insert super in there, and it's going to use the default one, right? So here's an example where super is not defined. Super would be defined here. So this is a subclass of object. Super is going to get automatically put in there and call the constructor of the superclass. And same here, this is extending number. Even when you write this value equals value, it's going to automatically go in here, and it's going to put super there. We're just going to call super here. We're just going to call it there. So super automatically does get put in there. So keep that in mind when you're doing inheritance questions. Remember, if you don't see super there, it's going to get called with the blank one. Okay, next up, 2D arrays. 2D arrays are pretty cool. They're like a grid, XY coordinates, but instead of XY, we generally talk about them as R and C, because we sort of say rows and columns. The rows are going left to right, the columns are going up and down, and we think about this like an array of arrays. So we have a list of arrays. If you notice here, the row is the first one because you can see the zero is not changing, right? This is the first row. The X is our grid, 0 is the first row, 1 is the second row, x2 is the third row. Now, because it's an array, this whole thing is an array, I'm accessing the columns now. 0 column, right? 1 and 2. So moving through an array, traversing, that's the important part, is you may get asked to traverse or run through the array. Easy enough to remember. Okay, so here's an example grid, and usually what we do is we say that the for loop, we have an outer and an inner for loop with row and column, or R and C for short. The row will just be kind of similar to a regular for loop that you see. The inner for loop will often need to know, well, how long is this row? Meaning how many columns do I have, right? Because this one is basically saying the row, how long is it, right? 1, 2, 3. So that's telling us how many columns there are. In the case here, I'm assuming that all columns are the same in each row. In this case, it's true. So I've used grid 0 to tell me, okay, tell me the first row, how long is the first row? And so let's keep going until that. That's limiting our loop. So the inner loop is processing the columns, the outer loop is processing the rows, and then we just print out the grid, row, column in that order, right? Row first, column second. And it would print out this 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, sometimes you're going to have to go in a different order, because sometimes they may say row major. If they want to be tricky, they'll ask you to print it out in column major order, where we're going increasing the columns, right? So as you see, the columns are changing on the, so the columns are changing on the outer loop and the rows are changing on the inner loop. So in this case, how would I change it back from row major to column major? This is row major. I would just switch these two values here so that column and row are switched. Now the inner loop is now the first one. So remember, it's not about what we call the variable, row and column. It's about which one comes first and which one comes second. So you just switch these two and you'll get column major order. Don't have to change these up here. Okay, let's talk about recursion. Recursion is, I think I've done a video on this, but the recursion is all about kind of doing a repeating thing, but in a different way, other than a while loop. You know, you can do it with while loop using iteration, but recursion is doing things in a different way, and it's often a little bit more simple to write, I guess. But sometimes it is a bit confusing. So I've used this example of eating dinner. Please excuse this missing curly brace down here. But this is an eat dinner function. As you see, eat dinner. And the things that define a recursive function is that the function has a call to itself inside here. So what we're saying is that if there is no more dinner, then return to regular life and the function ends. However, if there is more dinner, we're going to take a bite of that dinner and then we're going to eat dinner. And I'm going to call this function again. And it's going to repeat the process again and again. And eventually, it's going to hit this case here. There will be no more dinner. It will return to regular life. That means that this statement will finish and its version of the method will finish. And then that will mean that its version, this finishes in another one, and then another one finishes, another one finishes, another one finishes. They all finish and roll up and they're all done. So all these functions are sort of staying open until we hit this case here, and then it folds up. So let me show you an example, kind of simplify the example to show you your dinner. Let's see the code that's running, okay? So we have more dinner, right? So this doesn't run. We take a bite, and now we say eat dinner for the rest, right? Because this is my dinner that's left. And so then it runs eat dinner on the rest, and it keeps doing this whole process, right? Eating dinner, eating dinner, eating dinner. But then I'm done. And so I hit this case here, and then all of the previous eat dinner commands will finish as well, right? Because when this finishes, it doesn't go here, it goes down to here at the end, and the function is done. And so then I will basically be returning, and then everything will be done. So the key here when you're doing a recursion is to look at the base case. You can identify the base case because that's the thing that stops the recursion from happening. And then you have your recursive function call, which will keep calling and then maybe taking a little bit away, processing a small amount, and then calling the rest again with the function. So this is the two parts to a recursive solution. All right, I think that's it. So before I go, some general tips. Okay, so when you're doing the exam, watch your time. You'll have 40 questions in the MCQ in 90 minutes. Okay, in the FRQ, I think you'll have a different kind of time structure. Maybe, let's see, it'll be 90 minutes and I think 3 questions. And therefore it's 30 minutes per question. But I would try and look at it like 25 minutes per question. You will have to watch your time anyway. So in MCQs, you got 2 minutes per question, and then it gives you 10 minutes review time. Skip longer answers, like longer questions. So if a question looks like it's going to bog you down, lots of reading, trying to work it out, you're not getting anywhere, circle it and then come back later. Okay, don't miss the easy questions at the back of the test. Okay, you're not really choosing the order the College Board are choosing the order of the test. So you just go through, try and use your reading time if you can, but go through and find all the easy ones and do them first. Get the points. Point, everyone is nervous. You know, if I go take an exam, I feel nervous. Don't worry about it. Everyone's going to feel nervous. It's an equalizer. It's a great equalizer. Don't worry that you're feeling nervous. Everyone is feeling the same way. When you're finding solutions, try and find the simplest one. So most of these answers are going to require only 1 to 3 steps. Okay, you won't have to be solving complex equations here. It'll be 3 simple steps to get you to the right direction. So if you're going down this rabbit hole, maybe you've chosen the wrong way. Look for the elegant solution first. And the other thing is, like, you can really improve your odds if you eliminate the answers that are clearly impossible. There may be something in the loop or some condition which is popping out and says these 2 answers can't be right. Okay, so one small piece of knowledge about each question may give you the chance to eliminate 2 answers, at least 2 sometimes, and that may improve your chances from, sometimes it's like from, if there's 5 questions, that's 20%. You know, if you flip a coin or try and like guess randomly, that's 20%. But if you can eliminate the answers, now you've got a 50-50 chance. Okay, it's still not great, but you do improve your odds, and sometimes if you're really struggling, improving your odds is the best thing you can do. Okay, so good luck. I know the exam's coming soon. I hope you did well. That's all for this video.